So, good morning students, we are going to discuss about attachment molecules. In the previous classes, we had discussed about some problems related to the first law of combination. Now, let's move on to some other problems related to that. Let's see. Note on the problem. Okay. Now let's see the problem. So calcium carbonate decomposes on heating to form calcium oxide and carbon dioxide. Okay, they have given that. So in this we have to observe what are the reactants and the products. So as they are giving that, calcium carbonate decomposes means calcium carbonate, here it is the reactant, and product is calcium oxide and carbon dioxide. So they have given that 10 gram of calcium carbonate is decomposed and then 5.6 gram of calcium oxide is formed. So here they are not given about the carbon dioxide mass. Now what we have to do, we have to find the mass of carbon dioxide. Then if you find the mass of the carbon dioxide, then it is easy to measure, it is easy to calculate the mass of the product, and we can compare this with the reactants. So by if both the values are same, then we can say that this is obeys the first law, that is the law of conservation of mass. So let's write the reactants. Let's write the first equation, this one. Carbon dioxide. So calcium, let's say how much they given, when 10 gram of calcium carbonate. So the mass of calcium carbonate is 10 gram and that of calcium oxide is 5.6. So consider the mass of carbon dioxide is as X. Now if you subtract the value of carbon dioxide X from the calcium carbonate, then we will get the, so here, yes, we do subtract calcium oxide, then we will get the carbon dioxide mass. By that we can calculate the mass of carbon dioxide. So let's say that carbon dioxide, okay, then calcium carbonate plus, so if this value goes left side, then it will become minus. So calcium oxide, okay, calcium carbonate is, it is 10 and it is 5.6. So you will get 4.4. So now the mass of carbon dioxide is 4.4. Now again we have to add the value here. So now say we will take the same here once again. Now we have 10 gram. So I will write this here. So we know that it is 10 gram, calcium oxide is 5.6 and it is 4.4 gram. Now again if we add, so we will get 10 gram each in both reactant as well as in product side. So again this shows that as the reactants, the mass of the reactants is equal to mass of the product, then it shows that this chemical equation, it obeys the law of conservation of mass. So in the first problem what I discussed, they have given both the values, then just we had to add and we had to show whether it obeys law or not. In the second problem they are not given a value of one particular product, then we have to find that, then we have to compare. So this is another kind of problem. Okay, now we'll go to another type of problem, and a third one. It is just similar to the previous one that I discussed in the previous classes, and just try that. Just solve this as a homework. Okay, so let me read the problem. Copper sulfate crystal react with sodium hydroxide to form a blue precipitate of copper hydroxide and sodium sulfate. So this is the equation. So in this, what you had to find? First thing is that you had to find the reactants and the product. Let me say here, copper sulfate and sodium hydroxide, they are the reactant, and copper hydroxide and sodium sulfate, they are the product, and they have given their respective masses. Okay, so now what the thing is that you had to add the mass of the reactants and products. If the value is same on both the side, then you have to say whether it is belong to first law or not. Okay, this is the problem, and solve yourself and send me the answer what you will get regarding this. Okay, let's see one more problem. Okay, so let me read the problem. Potassium chloride decomposes on heating to form potassium chloride and oxygen. So here potassium chloride is the reactant and potassium chloride and oxygen are the product. So and they have given the value of potassium chloride and as well as potassium chloride. They have not given the value of oxygen. So as we did in the second problem, again this is also second type of problem. So find the mass of oxygen and compare the mass of product with the reactant. Again, after all finding that, then you have to give conclusion in both the cases, which law of chemical combination you use. So don't forget to write the conclusion after solving the problem. Okay, so these are the problems which are related to first law of chemical combination, that is law of conservation of mass. So after that, now let's move on to second law. Let's see that. Now second law, that is law of constant proportion. So here the law of constant proportion, it is also called as law of definite proportion. Law of definite proportion or law of constant composition. Law of constant composition. So we have discussed three laws. One is law of conservation of mass, law of constant proportion, third one law of multiple proportion. In that we had discussed law of conservation of mass. Now second law is law of constant proportion. This law of constant proportion is also called as definite proportion or constant composition. Okay, and this law of constant proportion was given by a scientist called Proust in 1779. This law was given by Proust. Then what actually the law of constant proportion states? So let's write that one. It states that elements in a compound, are fixed. Elements in a compound are fixed by same proportion mass. says by same proportion means the elements in a proportion in an element they have same fixed number of elements. So let's see that for example. Or you can define in another way. Say elements in a compound combined together in the same proportion by mass, by mass. So this law what it says that, so whatever the compound is there, in that particular compound the number of elements they are fixed. Let's see an example. Okay, let's see some examples. Say water. So water, it is made up of two elements, one is hydrogen and oxygen. Here the number of elements, actually the last is that the number of elements in a compound, while forming a compound, their number always fixed. The ratio is also fixed. See that if you say water means we always write it H2O only. We will not write as HO or HO2. So we will not write like that. Okay, we always water means it is H2O only. Why it is H2O means while forming in water, the two hydrogen has to compare with oxygen, and it is in the ratio of 1:8, or it is by 11:89 by mass. So if it is in this proportion, then only means the hydrogen it is 11 and oxygen is 89. If it is in that ratio mass, then only the hydrogen combine with oxygen and it forms water. And here the Proust has taken many sources. He has taken the water from different sources and undergoes decomposition. So whatever sample he has collected from different sources on decomposition, so they give the same mass. So he may take the water from a well, a pond, lake, whatever, okay, the different sources. So finally he come to know that the water it is consists of only this proportion only. So this shows that the mass of or the elements in a compound they are in definite proportion. That is what you call law of constant or definite, means the number of elements and their proportion it is constant in a compound. Say one more example. Let's take ammonia. So ammonia it is NH3. Okay. So if ammonia has to form means one nitrogen has to combine with hydrogen. Okay, and it is in the ratio of 14:3, means if the 14 parts of nitrogen combine with 3 parts of the hydrogen, then they form ammonia, and it is always constant, means the number of elements and their proportion in this compound, that is ammonia, it is always constant. Hence it is what we call law of constant proportion or definite proportion. So once again, so what actually the law of constant or definite proportion, this is that the elements, so elements in a compound, they are fixed by their mass, means their number and the ratio it is always in a definite proportion. So this is about the law of constant proportion. So here also in this problem you will get in this second law also there will be some problems related to that. So let's solve one by one. Let's take the problem. Okay. So here in an experiment 1.228 gram of copper oxide was obtained from 1.03 gram of copper, and in another experiment 3.672 gram of copper oxide gave on reduction 2.938 gram of copper. So show that these figures verify law of constant proportion. So here they have given two equations, two chemical equation. One is formation of copper oxide, another one is decomposition of copper oxide, and they have given values also. So the thing is that here what we have to show, that the elements, that is copper oxide is the compound. In that they have given that copper, the ratio of copper and oxygen is same. If the ratio of copper and oxygen is same in the both the experiment, then it obeys the second law, that is law of constant proportion. So okay, so here just try once, means what, let me explain in brief. If it is try to solve this problem, if it is not possible, we will solve in the I'll show that. Say for example, say copper oxide oxygen and it form copper oxide. Okay, so I will show one problem, the remaining problem we can solve this. See, they have given that copper oxide was obtained from copper. Then here what is the mass they are given? 1.288 gram, and copper is 1.03. So they have given copper and copper oxide, but they are not given oxygen. So here we had to find mass of oxygen. Okay, just put a question mark here. So means that you had to find the mass of oxygen. Then let's find out the mass of that. Copper oxide minus copper. So first let me take first oxygen so that you will get confusion. Oxygen, copper oxide minus, I have to subtract copper. Okay, 1.288 minus 1.03. Then you will get the value of so you will get 0.258 gram. So this is mass of oxygen. Now we have to compare the mass of, that is the ratio of copper and oxygen. If the value is same, then the same we have to compare the mass with the mass of another experiment. Okay, so let's me see this. So mass of copper is 1.288 and that of mass of oxygen is 0.258. So now we have to find the ratio of this. So I think you can write like this also, 1.288 by 0.258. So in proportion, so if there is no means, we can write value 1. So if you solve this, then you will obtain the value of 4, and it is 1. 4:1 means the mass of copper to that of mass of oxygen. By solving, by simplifying, you will get the ratio of 4:1. So this is the proportion, that is proportion of copper and oxygen in this experiment. This is the first case. Now we have to solve second case. So let's see second case, what they have given. In the second experiment, they have given that copper oxide on reduction means it decomposes, it gives copper and oxygen. So copper oxide is 3.672 gram of copper oxide. Reduction gives 2.938. Again we don't know the mass of oxygen. So let's find mass of oxygen. Mass of oxygen is equal to mass of copper oxide, or you can write directly copper oxide minus copper. So copper oxide is 3.672 minus 2.938. So if you subtract, you will get 12 minus 8, 4, you will get 6 minus 3, 3, and it is 15 minus 9, we have to subtract, you will get 6. Okay. Yes, next 0. So this is the value of mass of oxygen. Again we have to compare the same thing here also. So here the mass of copper is 2.938 and that of oxygen is 0.634. And if you take the ratio of that, so if you again simplify, you will get the same proportion, that is 4:1. So this shows that the ratio of, that is copper and oxygen in a compound copper oxide, it is same in the both the cases, and by this way it shows that it verifies the law of constant proportion. So remaining problems and concepts will continue in the next class. Thank you.